Imagine you had to explain a prediction to a colleague who trusts nothing they cannot follow. You would probably walk them through a series of simple questions, each one narrowing things down until the answer becomes obvious. That, in a single sentence, is a decision tree, one of the most intuitive models in all of machine learning. It makes a prediction by asking a sequence of plain questions about the features, like a flowchart. At each internal node, it tests one feature. Is age greater than 30 and branches accordingly? It works for classification and for regression alike, and the whole thing reads like a diagram you could draw by hand. Let us see how it actually thinks. Now, to appreciate a tree, it helps to hold it against a more familiar alternative first. Consider a linear model. It bundles everything into one global equation, a weighted sum of the features. Powerful, yes, but if someone asks why I made a call, you're stuck pointing at coefficients. There's no plain story you can tell about a single prediction. A tree, by contrast, is a readable flowchart of simple splits. Each step tests one feature and branches, so the path from top to answer is a short chain of yes or no questions. You can literally read the rule that produced any given prediction out loud and hand it to someone who has never touched a model. Here's the thing about a tree. It is grown, not written. Training builds it greedily, one split at a time, and the loop is easy to follow. Start with all of your training data sitting together at the root of the tree. Nothing is separated yet. So this top node is just the whole messy mix of every class you're trying to tell apart. Then search every feature and every threshold to find the one split that best separates the classes. Best is measured by a purity criterion, something like Gini impurity or information gain, which rewards splits that make each side more uniform. Once the winning question is chosen, branch the data left and right, and repeat the exact same search independently on each side. Every branch grows its own little subtree. Asking whatever question helps most for the rows that happen to land there. The tree deepens wherever the data is still tangled. Keep splitting until a node is pure enough to stop, and that becomes a leaf. Each leaf hands back the prediction, the majority class for classification, an average value for regression. Follow any path down, and you reach an answer. So what should you actually remember about how a decision tree behaves? 3 ideas carry the whole model. Fundamentally, it is a flowchart of feature tests. Each internal node asks one question. Each branch is an answer, and stacking those questions carves the data into regions that each get a single prediction. Every split is chosen greedily by a purity measure. The tree does not plan ahead. It grabs the locally best question at each step, using Gini or entropy to keep pushing each branch toward one clean class. Its gift is interpretability, and that is real, but a single deep tree overfits badly. It happily memorizes noise, treating flukes as if they were rules, and a tiny change in the data can reshuffle the whole structure. That instability is exactly why we rarely stop at just one tree in practice. All right, let us pull the essentials together into 4 takeaways. A decision tree predicts by asking a sequence of simple feature questions, branching like a flowchart until it reaches a leaf that gives the answer. Training grows it greedily, picking at each node the split that best separates the classes by a purity measure like Gini impurity or information gain. Its great strength is interpretability, needing little data prep and handling mixed feature types, but a single deep tree overfits and stays unstable. That very weakness is why ensembles like random forests and gradient boosting combine many trees. Want more machine learning explained this plainly? Standarity.com is where these break down one idea at a time.